In topic 1, you would have watched a video that showed you how to produce algorithms using both pseudocode and flow diagrams. In this video, we focus on the paper 2 on-screen exam, and we look at how to produce algorithms using pseudocode and flow diagrams that you may be presented with in your paper. So in the paper 2 on-screen exam, you will need to be able to convert algorithms which are presented to you in the form of flowcharts and pseudocode into high-level Python code. So just as a quick recap, a flowchart is nothing more than one method of representing the sequence of steps in an algorithm in the form of a diagram, and it uses specific symbols. We went over that video in how to produce algorithms in topic 1, so watch that if you need a refresh. Pseudocode, on the other hand, is a text-based alternative of representing the sequences of steps in an algorithm. It can be thought of as a simplified form of programming code. Indeed, the prefix pseudo means false or not genuine. Writing pseudocode allows us to lay down the logic of a problem in an almost like real code way without having to worry about all the actual strict rules and syntax of a particular language. Again, we covered this in a video under topic 1 if you need a refresh. So here's some algorithms presented in pseudocode on the left and a flow diagram on the right. And you would have seen this in the previous video that we looked at in topic 1. They do exactly the same thing. It asks the user to input 3 numbers, and then it will output which of those numbers is the largest. Now with this example, we're going to take the pseudocode version of the algorithm. In the paper 2 on-screen exam, you might have to write this in actual Python code. So you could just take the pseudocode one line at a time, and then you'd have to recall the syntactically correct lines of Python that you'd be required to write. So the first 3 lines are the input lines. We're asking the user to input 3 numbers and store them in 3 variables. So you can see here, this looks very similar. We've got number 1, number 2 and number 3 equals. They're going to be our variables. Then we've got int. That means whatever we're going to collect from the user, we convert into an integer. Then we open our brackets and say input. So that's the command for receiving input from the user. And open the brackets again and provide a prompt to the user in quotes. So enter your first whole number, your second whole number and your third whole number. Make sure you end those strings with quotes and close both sets of brackets. Now, technically, if we're converting this program into high-level code, we probably should have also written the comment at the top, because we can see here we have a comment in the pseudocode. And of course, you would do that in Python with the hash symbol followed by your comment. We then reach an if statement. If number 1 is greater than number 2, then. And in Python, that becomes if number 1 is greater than number 2, colon. Directly inside this if statement, we have another if statement. So we've got another line there, and notice how it's indented because we need to do that in Python, and the colon's being used to terminate the end of that if statement there. Now we output a line of code to the screen, or a line of text to the screen. So we've got the command print, open brackets, the largest number is, and that's in double quotes, and then we're going to concatenate that string to the contents of the variable number 1, but don't forget we stored that as an integer, so we're going to cast that and convert it back to a string. So the largest number is, and then we've got plus, convert the variable number 1 into a string. Then we have an else statement, and we must put a colon on the end of that, and then another print line, although this time we're printing out the contents of number 3. Now that's the inner nested if statement dealt with. Going back to the outer if statement, we now reach its else. So we've got another else with a colon, and notice that's indented to line up with the outer if statement. And then we jump straight to another nested if statement, this time if number 2 is greater than number 3. So it's the same as before with the colon on the end. We then have another print line like before, but we're printing out number 2. followed by an else and a colon, and another print statement, this time printing out the contents of number 3. You'll notice that Python doesn't need any way of terminating the if statements. So in a lot of programming languages, you'll say if, else, but you'll need some kind of end if. And it's quite common to see this end if or end for loop or end while loop in pseudocode. But Python doesn't need any explicit mention of ending a construct. It's done automatically by the fact that the indentation has changed. So that's actually the complete program written out in Python code. Okay, so here's another problem presented in both pseudocode in the left and a flow diagram in the middle. And this is an algorithm which calculates how much carbon to dose into a fish tank to keep the nitrate level safe. Now this time we're going to take the flow diagram and turn it section by section into real Python code. But it's a very similar process as before. It's just remembering the syntax. So the first thing is they need to enter a number between 1 and 50, and we want them to be able to enter a number with a decimal point. So I've got a variable called nitrate, and that's going to equal, and I'm going to cast whatever they input into a float. So that's a data type that can hold a decimal point. So I've got float brackets input brackets, and then a prompt to the user in double quotes. Enter the nitrate level, a number between 1 and 50. Remember to close the double quotes and close both sets of matching brackets. Now we've stored the nitrate level in a variable called nitrate, we hit our first if statement. If nitrate is greater than 10, and of course we terminate that line with a colon because that's how you construct an if statement. If it is greater than 10, we're simply going to print to the screen dose 3 mils, and we put that in brackets and the string inside double quotes. Now if nitrate isn't greater than 10, we're going to have another if statement. Now we're going to use an elif here, an else if, because we've got a number of if statements and we can do them all in one construct. So we're going to say elif, so if nitrate is greater than 2.5 colon, and if it is, we're going to do another print statement and print out dose equals 2 mil. But if that's not the case, we're going to ask again with another elif. We're going to say, well, okay then, is nitrate greater than 1 with a colon? If it is, we're going to print out dose 1 mil. And finally, if none of those previous elif statements or the original if statement were true, we can now just say else colon, so in all other situations, print dose is 0.5 mils. And that's the end of our program because there's no need to terminate the if statement with an end if. In Python, it simply knows when to terminate the selection statement based on the indentation.